Today we're on unit 4.7. Okay. This is unit 4.7. Thanks. And we're working on word problems. Now, on this homework, yes, you have to write down the words. Or excuse me, on the notes, yes, you have to write down the words. On homework, you are not going to have to write down the words. So don't worry. I just want equations. So, we are working on word problems with parabolas. There's only a couple of examples. And to start with, if I tell you a ball is thrown vertically upward. Okay, a ball is thrown vertically upward with an initial speed of 90 feet per second. That is like really fast. Okay. With an initial speed of 90 feet in the first second. Okay. This was possibly thrown from a cannon. Okay. Its height after t seconds, t would represent time here. Its height after t seconds is given by h equals 90t minus 15t squared. Okay, so this is the equation of the height of this ball. Okay, someone like figured this out. It wasn't me. Okay, the A question is, I want to know how high does the ball go? How high does the ball go? Okay, so essentially we are making a parabola. Okay, so if I throw something, it is going to be thrown up and it's going to make a parabola shape. Okay, now we do not know if it starts at 0. Well, actually, we do know that this starts from the ground. Okay, so it starts from the ground, so we're starting at 0. This is going to go up and it's going to come back down. Okay, it will make a parabola shape. Even if you think you're throwing something exactly straight up in the air, it is going to make a parabola shape. So I want to know, how high does the ball go? So what am I essentially asking here for the what? The maximum. Okay, we want to try to find what is the maximum. Now, if you label this correctly, the y-axis is height. You know that because in this parabola, h is in the y spot, and the x-axis is time. And you know that because it is in the x spot. So I'm going to know how high does the ball go, so I'm essentially going to find the maximum. Okay, we will start that by finding line of symmetry. Remember, line of symmetry is x equals negative b over 2a. Now, if you go back and we label, okay, I'm going to label my ABCs here. This is not written in the correct format. Okay, it's not written in ABC form. So we're going to start by labeling your ABCs. Here, a would equal what? Negative 15. Remember, a is always the number, the coefficient attached to the x squared, or in this case, the t squared. B will equal 90. C is 0. There is no C here. But we don't need C, so it's not a really big deal. Okay? Now, if I plug this in, we're going to get negative times 90 over 2 times negative 15. Negative 90 over negative 30. So that equals a positive 3. So the x-coordinate is 3. Okay, so we know that my line of symmetry, right down here, will be at x equals 3. In the homework, you do not have to draw graphs. No. I'm just trying to show you kind of what this means. Yes? We're not doing a boomerang right now, but thanks for sharing. Thanks for asking random questions. Okay, so x equals 3. So we know that my time is at 3. So how high does the ball go? Does 3 seconds have anything to do with how high the ball goes? No. No, it's how long it takes to get there. okay? So I'm not done yet, okay? This is 3 seconds. Now to find the height, I have to plug back in. So we're gonna find the y coordinate of the vertex. So h equals, so if I'm finding the vertex, h equals, we're gonna plug in 3. 90 times 3 minus 15 times 3 squared. So 90 times 3 gives you 270 minus 15 times 3 squared is 9. If we simplify, we're going to get 270 minus 15 times 9 is 135. So subtract, we get 135, and we are talking about 135 what? Feet. Okay? So if I'm trying to figure out how high, does the ball go? How high does it go? 135 feet. Okay, so your vertex here would be at 3,135. Okay? This is basically what we were doing yesterday, okay? But today we're talking about things being thrown. Yesterday we were talking about revenue. But both of them are still the same type of thing. We're finding the vertex. That's it. Because I'm going to show you another one in just a second. Okay, just hold on. We're going to do a little more with it today. So, for B, I want to know how many seconds does it take to reach maximum height? Yes. Okay, so I want to know how high does it go. Now I want to know how many seconds does it take to reach maximum height? We already did that. 3 seconds. Okay? So actually, and almost always on these types of questions, they ask you the second question you've already done. Okay? It's always the first thing that you find. So how long did it take to reach maximum height? 3 seconds. Okay? Now, it is important that you include the seconds. Okay? Do not just write 3. I want you to include the label. So it is 3 seconds. Okay? The next portion, the C portion, is I want to know, when does the ball hit the ground? When does the ball hit the ground? Yes, Bryce?
Is that the x-intercept?
That is the x-intercept, exactly. Because we want to know the ground is basically at height of 0. So Bryce is right. We're going to find what is the x-intercept. So here, how do you find the x-intercept? Plug in 0 for y. So the height, when is the height 0? So 0 equals 90t minus 15t squared. This is just a GCF. What is the GCF here? 15t. So 15t times 6 minus t. Okay, set these each equal to 0, and we would get t equals 0. Well, great, it hits the ground at 0. All that really means is it started at 0. Okay, obviously I'm not asking for this one. If you set this equal to 0, 6 minus t equals 0, move the t over, we also get 6 equals t. So 6 is also when it hits the ground. So it doesn't make any sense to hit the ground at 0. That's where it starts. But it does make sense that at 6 seconds, it will hit the ground. Question?
Where did you get 16?
Where did I get 6t? 6 equals t?
No, where you have 15t, parentheses, 16.
I factored out. I took out a GCF.
Oh.
So we're factoring. Yes, Dylan.
Okay, so is it coincidental that the line of symmetry is half the...
Right, it is not coincidental. Now, Dylan has found something that, no, wait, okay. A lot of times, it will be symmetric, and so your line of symmetry is halfway in between, or if you double your line of symmetry, a lot of times, that's when it will hit the ground. But wait for the next example, okay? I do not want you to always think that it will hit the ground at double the amount of time as line of symmetry, okay? So just wait till the next example, okay? Now, there is also a D portion here. The D portion is, I want to know at what height is the ball At what height is the ball after 4 seconds? At what height is the ball after 4 seconds? So essentially, I want to know if this is 3 here. We said that was 3. This is 6. I want to know, where is it at 4? At what height is it at 4? How could you do that? Plug in. Okay? Plug into your equation. So h equals 90t minus 15t squared. Time is time. T stands for time. So plug in 4. So what is the height at 4 seconds? So 90 times 4 minus 15 times 4 squared. If we work that out, we got 360 minus 15 times 16. Sorry, I'm running out of room. That's 360 minus 15 times 16 gives you 240. So your height is 120, and it's 120 what? Feet. Okay, so where is it at 4 seconds? It's 120 feet. And does that make sense? Yes, okay, if the highest it gets is 135, it should be lower. Okay, so if you get something that's higher, that doesn't make any sense. Okay, would it make any sense if I got a negative answer? No. Okay, it has to make sense. So when we're doing word problems, please use some critical thinking. Okay.